Let's learn about how to solve one-step equations, and while there's different types of one-step equations, we're going to be specifically focusing on ones that have sums and differences, or adding and subtracting as the operations in them, okay? So first of all, what is an equation? An equation is a mathematical statement that sets two expressions equal to each other. So we're going to say if we have an expression equal to another expression, then that becomes an equation, all right? So we're going to go ahead and see if we can solve those today, all right? Then we have this thing called a one-step equation. Later on, there's ones with more than one step, but we're going to be focusing on just one-step ones here. When it has a one-step equation, basically we're just going to have one operation. So for the purpose of this lesson, we're going to be only focusing on equations that have one step. Either they're going to have an addition as the operation, or it's going to be subtraction as the operation. What's a solution to an equation? This is basically going to be a number that's going to make the equation true, where we can make the expression on the left side and the right side equivalent. So they're basically going to be the same value on both sides here. So we're going to have a left side and a right side, and when they're equal to each other, that means we found a solution for the equation. So if we find a number that makes it true, that's going to be the solution. All right, so what is an inverse operation? Some people call an inverse operation sometimes an opposite operation, but it's important to know that if you have the inverse of addition, basically what undoes addition, it's going to be subtraction, and what undoes, what's the inverse for subtraction, it's going to be addition. So these are called inverse operations. Using the word inverse is a little bit more appropriate to you, so try to learn that vocab word of inverse, and basically these undo each other. Okay, so addition and subtraction are inverse operations. Then we have this thing called the addition property of equality. This lets you know that you can go ahead and add the same number to both sides of an equation and it's still going to be true. Okay, so you can go ahead and add any number on both sides of an equation as long as you're adding the same number, and you are allowed to do that. What about the subtraction property of equality? Well, it's very similar. It's basically just saying we can go ahead and subtract a given number from both sides of the equation. As long as it's the same number, then you can do it to both sides of an equation and it'll still be true. What's an opposite? Well, an opposite is a number that is equidistant from 0 as another number. So keep in mind, if you add opposites like 3 plus -3, that's 0, or -2 plus +2, that's 0. So basically, you're going to say that you're always going to be getting 0 if you add opposites together. So opposite values are always going to add to get 0. That's really important here. This right here is something called the additive inverse property. Not super important right now, but basically if you can get 0, that's really helpful when you solve equations. Then we have something called the identity property of addition. This basically just says if you go ahead and add 0 to any term, you're always going to be getting that term itself. So for example, if you were to say, if you had like x plus nothing, that's just going to equal x, or x plus 0, that would just be equal to x. Seems kind of silly right now, but it'll make more sense when we use that in some examples later. Okay, so let's go ahead and apply and see how we can use some of these vocab words in some examples. So let's see, for the first example here, let's go ahead and find the solution from a solution set. So we have an equation here. On the left side, we have this expression x plus 2.9, and on the right side, we have this very short expression of 6.4. There's only one value, one number that x could be here that would make this left side equal to this right side. And so we have this solution set. The solution set is right over here. It's in all the numbers in these braces. Basically, we're saying we have a few different options that x could be, and only one of these is going to be correct. So we have to figure out which one it's going to be. So let's start out with like this -5.3. If you took this -5.3 and you substitute it in for x and you add 2.9, the question is, would you get positive 6.4? And I don't think you would, because a negative plus a positive here, the negative is more negative than the positive is positive, I guess, right? So it's still going to stay into the negatives here. There's no way we would get to positive 6.4. So it can't be this -5.3. What about -3.5? Well, if you plug that one in for x, or substitute it rather, and you add 2.9, well, the 2.9 again is not enough to bring this into the positive, so it can't possibly equal the 6.4 here. So that's also not going to be the answer. All right, maybe this 2.4, if we take this 2.4 here and add 2.9, I guess ask yourself, what is 2.4 plus 2.9? At least we're going to get a positive number. I believe this would be 5.3, so that's not quite 6.4, so it's still too small here. What if x is 3.5? Well, 3.5 plus 2.9, if we add those, oh, that is exactly 6.4. So this right here actually would be our solution. X would have to equal 3.5, which means it can't equal 5.3. So x here we can say would be equal to 3.5. That would be the solution for this equation. So if you're given a solution set and you're asked to find what the solution is, you just basically can see which one makes the most sense when you plug it in. It's got to make the left side and the right side equal each other. And in this case, 3.5 plus 2.9 does equal exactly 6.4. If you go ahead and just verify this, you can say if you substitute x is 3.5 and you go ahead and add that 2.9, then you should get this 6.4. And if you go ahead and simplify the left side, you can combine these constants over here on the left side. The 6.4 does equal 6.4 here, so we know that this is correct, right? So this is a true statement. The left side, the left expression here does equal the right expression. They're very short expressions, though. They're just constant terms. All right, let's try another example here. If we take a look at B, we have this equation y take away 5.34, that's a difference here, is equal to 3.29. So what could the value of y be? Well, we have a few different options that we're going to choose from here. We have 1, 2, 3, 4, 5. We have 6 different numbers to choose from. Let's see, if we start off with maybe this negative 7.63, if we take negative 7.63 and we take away 5.34, keep in mind that if you rewrite this as an addition problem, it's negative 7.63 plus negative 5.34. Now, negative plus a negative is going to be more negative. So for that reason, these first two answer choices are actually not going to make any sense here. If you take negative numbers and then you take away a number, a positive number here rather, it's just going to become more negative. So neither of those are going to work here. What if we try 2.05? What if we plug in 2.05 here? Well, if we take 2.05 and we take away 5.34, that's also going to be a negative number because we're taking away more than what we have. And we're trying to get to this positive 3.29, so there's no way that's going to work either. Maybe the 6.83 is promising. Let's go ahead and plug that in here. 6.83 take away 5.34. I don't think that's enough either because I think this is going to be 1 point something, right? 6 point something minus 5 point something. Looks like that would be $1 something if you're talking about money here. So again, we're trying to get to 3.29, so I don't think that's going to work either. What about this 8.63? If we plug that in here for y, maybe this could work. Let me see here. Let's do 8.63. Let's minus this 5.34. Let's see, we could borrow, this would be a 5, this become a 13. 13 minus 4 is 9, 5 minus 3 is going to be 2, so far so good. 8 minus 5 is going to be 3, so check this out, this does match exactly what we were looking for here, so this must be our answer, our solution, 8.63 here. So we can go ahead and say here that y would be equal to 8.63. That would be our solution for this particular equation, right? If you go ahead and substitute this in, we can say 8.63, this would just be some good proof here, minus the 5.34 does equal the 3.29. And we just subtracted to check, but the 3.29 is the value of the left side, and the right side is equal to also 3.29, so these expressions are equivalent, so we know that our answer does make sense here. All right, so that's just example 1 where we just went ahead and found a solution from a solution set. We just had to choose and find out which one makes sense. All right, let's look at example 2 where we go ahead and solve an equation. This time you're not going to get a solution set. We actually just have to go ahead and solve it. Each of these are going to have addition as the operation. All right, so if addition is the operation, what's the inverse operation? The inverse operation is going to be subtraction. So we're going to go ahead and use subtraction here. So let's go ahead and take away 3/4 from the left side and take away 3/4 from the right side of this equation. If we go ahead and do that, see what's going to happen here. This positive 3/4 and this negative 3/4 are opposites, right? We kind of said earlier that if you add opposites, you're going to get 0. So 3/4 plus negative 3/4 or 3/4 minus 3/4 is going to be 0. So we're going to get x plus 0 I'll go ahead and write x plus 0 here, and that's going to be equal to whatever is on the right side, or the answer to this problem here, right? So we just use the additive inverse property. You could check out the vocab from earlier, and that's how we got 0 here. Opposites always add to get 0. But the right side of the equation, we're going to go ahead and see what's 9/10 minus 3/4. Well, notice these denominators are not the same. So when's the first time 10 and 4 meet? Their LCD, or LCM, is going to be 20. So we do times 2 times 2, and then if we go ahead and do times 5 here, then we can rewrite these fractions and say, okay, 9/10 is the same thing as 18/20, and then 3/4 is going to be the same thing as 15/20. And you can go ahead and subtract these, and we're going to end up with 3/20. All right, so x plus 0 is the left side. Again, the 3/4 minus 3/4 got a 0. And then on the right side, this 9/10 minus 3/4 we just found out is going to be 3/20. Now, there's something called the identity property of addition. We said in the vocab earlier, it's if you add 0, it's going to stay the same. It kind of sounded silly earlier, right? But x plus nothing is just x. That's using that property. And so x would be equal to 3/20 here. So this would be our solution. All right, so we had addition as the operation. We use subtraction as the inverse operation. The inverse will always help us get 0 here when we're talking about adding and subtracting. So here's the 0. That's that additive inverse property. And then if you go ahead and say x plus 0 is x, that's using the identity property of addition. Besides that, the right side was pretty straightforward. You're just subtracting two fractions. We needed common denominators, but the rest of it wasn't too bad here. We're actually just going to move this down a little bit so it's not little interfering with that 3/20 in case that's hard to read. All right, trying one more here. It's of this type where you have addition as the operation. Let's go ahead and use subtraction to get 0. So if we have addition here, we're adding 1/6. Let's go ahead and take away 1/6 from both sides here. Okay, so that's using the subtraction property of equality if we do it to both sides. If we go ahead and do that, this positive 1/6 and negative 1/6 are going to combine to make 0. So it's going to be y plus 0 on the left side of this equation. And on the right side, what are we going to get? Well, we have 2/3 minus 1/6. I think the first time this 3 and 6 meet for common denominators is going to be 6. So we can just do times 2 here. So 2/3 is the same thing as 4/6, and then 1/6 is just going to stay the same here. 4/6 minus 1/6 is going to be equal to 3/6, and then we can simplify this by dividing top and bottom by their GCF of 3, and that's going to just say that's going to be 1/2 here. Okay, so let's see, this 2/3 minus 1/6 is just going to be 1/2. Then what are we going to do next? Well, we're going to use the identity property of addition. Y plus 0 is really just y. And so y is going to be equal to 1/2. This would be the only number that y could be equal to that would make this equation true. For both of these examples, if you take this 3/20 and you plug it in right here for x, if you add on 3/4, you can check it, it will equal 9/10. It must, okay? For this one, if you take this 1/2 and you substitute it in here for y, if you take 1/2 and you add 1/6, you will get 2/3. It must be true. Let's try a couple quick examples if our operation is no longer addition. In this case, they are subtraction. So if you take a look at A and B, notice that there's subtraction for both for the operation. So we're going to use addition, which is the inverse operation, so that we can get 0 for both of these. So think about this as a negative 7/8 and think about this as a negative 1/4. Let's do the one on the left first, though. So to get 0, the opposite of this negative 7/8 is going to be adding 7/8 or positive 7/8. We're going to add that to both sides. Now this is called the addition property of equality, right? We're allowed to add something to both sides of the equation if it's the same value. So let's see here. What's negative 7/8 plus 7/8? Well, those are opposites, so opposites add to get 0. So we have x plus 0. That's that additive inverse property. And on the right side, we have to figure out what 1/6 plus 7/8 is. Now they have different denominators, so we need to get common denominators. So 6 and 8 meet at 24 for the first time. So we should do times 4 times 4. And we should do times 3 times 3. So for that first fraction, if we do that, it's going to be 4/24 plus, and if we do times 3 times 3, that's going to be 21/24. So adding these together, we're going to get 25/24. So that would be the right side of this equation. And then using the identity property of addition, x plus 0 is really just saying is x. So x would be equal to, up to you if you want to write an improper fraction or mixed numbers if it's not a word problem. I'm going to write a mixed number. It's going to be 1 and 1/24. So this would be the only number that x could possibly be. That would make this equation true. You could take this and substitute it in right here if you wanted to check it, right? And do 1 and 1/24 minus 7/8. And I promise after you simplify, it'll equal 1/6. All right, let's try another example here. Notice that the operation is subtraction. So what's the inverse operation? It's going to be addition, right? So let's go ahead and add 1/4 to both sides. That's called the addition property of equality. So you can add the same number to both sides of the equation and it'll still be true. So we have a negative 1/4 and a positive 1/4. Hopefully this is getting familiar now. That's going to combine to make 0. So we have y plus 0 on the left side of the equation. And on the right side, we have to add 2/3 and 1/4. Now, again, these have different denominators. So when do 3 and 4 meet for the first time? I think it's going to be 12, right? So it's going to be times 4 times 4 and times 3 times 3. So let's see, these new versions of these fractions rather are going to be 8/12. That's the same thing as 2/3 plus 3/12, which is the same thing as the 1/4. And if you add these, we're going to get 11/12. All right, so if you go ahead and add 2/3 plus 1/4, after you get common denominators, you'll find out it's going to be 11/12. Now, what's y plus 0 the same thing as? That's just y, using the identity property of addition. So y is equal to 11/12. And again, while we're not doing it right now, you can go ahead and take this 11/12, substitute it in for y. If you do 11/12 minus 1/4, I promise it's equal to 2/3. All right, here's one final example. In this case, for example 4, let's try an application problem here. So we're going to try to look at a situation and see if we can write an equation and then solve it. All right, so after buying some clothes, Elena now has $47.28 in her bank account. Okay, so that's after buying clothes. So we hopefully know if we're going to be adding or subtracting money if we're buying clothes. And so if the clothes Elena bought cost $27.58, it says to write and solve a one-step equation to determine how much money Elena originally had. So originally is what she had before she went to buy clothes. It says to find that out. So we actually don't know right now what Elena started with. So we can use a variable to represent that. Maybe we could use something like M for money, right? So we don't know how much she had before she went shopping. So if she's buying clothes and she spent money, that means she is losing money in a sense, right? But she's gaining clothes. So how much is she spending? Well, she's spending $27.58. So hopefully that makes sense. When you spend money, that amount in your pocket kind of goes down, right? But what's the resulting amount? How much does Elena have after shopping? Well, the problem does say that Elena now has $47.28. That's the resulting amount after she goes shopping here. So $47.28 is how much is left after shopping. So we had some unknown that Elena started with, but they went shopping, so we're subtracting money. However, we end up with this much in their pocket or bank account, right? So let's go ahead and see if we can use what we have been practicing and learning here to figure out how much Elena had before she bought these new clothes. So I'm just gonna go ahead and write down the equation. Let's go ahead and just do that. And how are we going to solve this? Well, what's our operation? Our operation is subtraction. What's the inverse operation? The inverse operation for subtraction is addition. And so what's this property called? You can look at your vocab sheet if you have forgotten. It's a property that allows you to add the same number to both sides of an equation. And if you remember, that's called the addition property of equality. So we have this negative 27.58 and this positive 27.58. And when you combine those, you're always going to end up with 0 since those are opposites. That's called the additive inverse property, right? So if you add these two opposites together, we end up with 0. Now on the right side of the equation, we have to go ahead and add these two values together. So let's go ahead and do so. I'm going to take this 47.28. And let's go ahead and essentially unspend the money or put the money back in Elena's pocket or wallets here. So let's go ahead and add this back into her account. 8 plus 8 is 16, carry the 1. This will be 8 here, put a decimal. 7 plus 7 is 14, carry the 1. And this would be 7 here. So if we take the 47 28, and we add on the $27.58, then this is what Elena must have had before. So this is going to be $74.86. Okay. Using the identity property of addition, we can drop the 0 here and say the amount of money that Elena had before shopping was $74.86. So here we wrote a one-step equation to represent the situation. Then we went ahead and used the addition property of equality, where we add the same number to both sides. That's really nice to do here because this then becomes 0. That's the additive inverse property. Then anything plus 0 stays the same, so that's going to be the identity property of addition. And so in conclusion, we can go ahead and say that Elena originally had $74.86 before shopping. This would be a good sentence to summarize what we just figured out. All right, so there you have a lesson on solving one-step equations. Kind of in summary here, what we want to basically say is we have these one-step equations. There are other ones that we'll learn in the future, but in this particular ones, everything was either a sum or a difference. If you see addition in one of these problems, you'll use subtraction to solve it. If you see subtraction, then you'll use addition. Basically, when you go ahead and add or subtract on both sides, that's called the addition property of equality or subtraction property of equality. But basically, when you have those opposites, you're always going to end up with getting 0, and that's called the additive inverse property. The process of getting 0, that's the property you're using. And then when you go ahead and get rid of the 0 because you don't need to write it anymore, like x plus 0 equals x, we saw that many times in each of these practice problems, that's called the identity property of addition. All right, so now that you have a little bit of background on how to handle some of these problems, go ahead and practice and try on your own.